Oh, we're taught that the speed of light is just a very large number, a technical ceiling, a challenge for engineers, a barrier that exists because our machines are still too weak. That belief is wrong. The speed of light is not a limit imposed on technology. It is a limit imposed on reality itself. Nothing slows down because light happens to be fast. Light is fast because the universe is structured in a way that does not allow anything faster. And that distinction matters. We can measure the speed of light with extraordinary precision. We can calculate its effects across interstellar distances. We can synchronize satellites and predict atomic transitions using it. Modern physics depends on that number, but most explanations never ask what that number actually means, because the speed of light is not really about light. It is about space, it is about time, and it is about the deep structure that binds them together. You've probably heard the standard explanation. As an object approaches the speed of light, it requires more and more energy, until reaching light speed would require infinite energy. This statement is true. And yet, it avoids the real problem. Why should energy behave this way at all? Why should motion distort time? Why should space resist acceleration with mathematical precision? Why does the universe enforce a speed limit instead of allowing motion to increase freely? These are not engineering questions. They are structural ones. And this is where Richard Feynman's insight becomes important. Feynman did not treat the speed of light as a property of photons racing through space. He treated it as a signal that space and time themselves are not passive backgrounds. They are active constraints. The speed of light does not describe how fast something moves through space. It describes how space and time relate to each other. Change one, and the other must adjust. That is why clocks slow down. That is why lengths contract. That is why cause and effect remain intact. Not because objects struggle to go faster, but because space-time will not allow a different ordering of events. If something could exceed the speed of light, effects could precede causes. Information could arrive before it was sent. Reality would lose its logical structure. So the universe does not permit it, not as a rule added later, but as a condition built in from the start. The speed of light is not the fastest thing in the universe. It is the speed at which the universe itself allows change to propagate. And once you understand that, the question, why can't we go faster, disappears. It is replaced by a more unsettling one. Why is reality built this way at all? This version is locked unless you find a specific flaw, a word, a sentence, the logic, or the flow. If you do, point to the exact line. At first, the speed of light looks like a statement about movement, something traveling very fast, a particle crossing space at an extreme rate. That interpretation feels natural. It is also wrong. If the speed of light were simply about how fast light moves, then its value would depend on who is measuring it. A moving observer should see light slow down or speed up, the same way they would see a thrown ball behave differently. But light refuses to do that. No matter how fast you move, no matter the direction, no matter the frame of reference, the measured speed of light is always the same. This is not a coincidence, and it is not a quirk of light. It is a statement about space-time. When Einstein took this seriously, he reached a conclusion that feels backward at first. Space and time must change so that the speed of light does not the other way around. If two observers are moving relative to each other, they do not agree on distances. They do not agree on durations. They do not even agree on what events are simultaneous, but they do agree on the speed of light. Always. This is why time slows down. This is why lengths contract. This is why clocks disagree. Not because objects are malfunctioning, but because space-time is adjusting to preserve a deeper consistency. The speed of light is not a speed through space. It is a conversion factor between space and time. It tells you how much space corresponds to a given amount of time so that cause and effect remain intact. Feynman emphasized this point repeatedly. He warned against thinking of light as something racing through an empty arena. Instead, he treated the speed of light as a structural constant, a rule that defines what space-time is allowed to be. This is why asking what would happen if we went faster than light is already a mistake. It assumes space-time would remain unchanged while motion increases. But space-time is not passive. it reacts, and it reacts violently. As an object approaches the speed of light, energy does not increase smoothly. It diverges, not because the object is resisting motion, but because spacetime is resisting a violation of its own structure. If faster-than-light motion were possible, different observers would disagree about the order of events. An effect could occur before its cause. Information could arrive before it was sent. The concept of before and after would lose meaning, so the universe does not allow it, not as a preference, not as a safety feature, as a necessity. The speed of light is the speed at which causal structure holds together. It is the maximum rate at which influence can propagate without breaking reality's internal logic. This is why light speed is the limit, not because light is special, but because space-time is, and once that is clear, another question emerges. If the speed of light defines what space-time allows, then what exactly is space-time made of? And why does it enforce rules that even energy cannot overcome? That is where the problem deepens. The speed of light is often described as a speed limit. That phrase is accurate, but it hides what is really at stake. The limit is not about velocity, it is about causality. Causality is the simple idea that causes come before effects. It feels obvious, so obvious that we rarely question it. But in physics, causality is not assumed. It is protected. Once you accept that the speed of light is the same for all observers, a strange consequence follows. Different observers can disagree about the timing of events. Two flashes that seem simultaneous to one observer may occur at different times for another. This is not an illusion. It is how space-time works. Under normal conditions, these disagreements do not cause problems. Cause still precedes effect for everyone involved. But this only holds because no signal travels faster than light. If faster-than-light motion were possible, that protection would fail. In some frames of reference, an effect would be observed before its cause occurred. Information could be received before it was sent. This is not science fiction. It is a direct consequence of how space and time transform, allow faster-than-light signals, and the logical order of events collapses. Feynman understood that this was not a technical inconvenience. It was a structural disaster. Physics does not merely describe what happens. It preserves internal consistency. And causality is one of the deepest forms of that consistency. The universe does not prevent faster-than-light travel by gradually increasing resistance. It prevents it absolutely. The equations do not bend, they break. This is why energy requirements diverge as the speed of light is approached, not to punish acceleration, but to block access to logically forbidden states. Think of it less like a wall and more like a contradiction. Trying to exceed the speed of light is like trying to define a square circle. The problem is not effort, the problem is meaning. Space-time is structured in such a way that certain configurations simply do not exist. No amount of energy can produce them. No technology can access them, because they would undermine the coherence of reality itself. This reframes the entire question. The universe is not saying, "You are not allowed to go faster." It is saying, "There is no consistent reality in which that motion makes sense." The speed of light is not enforced by particles or forces. It is enforced by logic, by the requirement that events remain orderable, that causes remain causes, that effects do not appear from nowhere. Once this is understood, the speed limit stops looking arbitrary. It becomes inevitable, but it also raises a deeper issue. If causality is protected so absolutely, if space-time is willing to distort time and energy to preserve it, then causality is not emergent, it is foundational. And that leads to a more unsettling question. Is space-time built to preserve causality? Or is causality the reason space-time has the structure it does? That question has no easy answer, and physics does not pretend otherwise. By now it should be clear that the speed of light is not a practical restriction, it is a definition. In everyday thinking, we treat space and time as separate things. Space is where events happen. Time is when they happen. Motion connects the two. This intuition feels natural. It is also misleading. In modern physics, space and time are not independent. They are woven together into a single structure, and the speed of light is what fixes the scale of that structure. Change the value of the speed of light, and you do not merely change how fast signals move. You change what counts as time. You change what counts as distance. You change how events are ordered. The speed of light tells space-time how much space can be traded for time without breaking causality. It is not measured within space-time. It defines space-time. Feynman emphasized this distinction whenever students tried to imagine light as a thing racing across a background. He warned that this picture puts the explanation backward. Space-time is not the stage on which light performs. Light reveals what the stage is made of. This is why the speed limit appears everywhere, not just in optics, not just in electromagnetism, in gravity, in particle physics, in the structure of field equations. The same constant governs how clocks tick, how rulers measure, and how energy transforms. That is not coincidence, it is coherence. Once this is accepted, the idea of going faster than light loses its usual meaning. Faster than light compared to what? Compared to which clock? Which ruler? Those quantities are not fixed, they adapt. What does not adapt is the causal structure, the network of which events can influence which others. That structure is absolute, and the speed of light is its boundary. This is why the universe does not permit shortcuts, not through space, not through time. Any such shortcut would punch a hole in the ordering of events. From this perspective, the speed of light is not a limit we discovered. It is a constraint we uncovered, a constraint that was already there, shaping reality long before measurement. Physics did not invent this rule. It noticed it, and then rebuilt its understanding of space and time around it. This explains something subtle. Why the speed of light appears in equations even when light itself does not. Why massive particles obey it. Why gravity respects it. The limit is not about photons. It never was. It is about the architecture of reality itself. And that brings us to the final tension. If the universe is structured to preserve causality above all else, then the speed of light is not the deepest rule. It is a consequence. So what is the underlying principle that makes causality so non-negotiable? That question does not have a clean mathematical answer, but it cannot be ignored. One of the most repeated explanations for the speed of light limit sounds simple. As you approach the speed of light, you need more and more energy, until reaching it would require infinite energy. This is correct, and still misleading. It makes the problem sound mechanical, as if the universe is pushing back harder the faster you try to go. But that is not what is happening. Energy does not increase because motion is becoming difficult. It increases because the definition of motion is breaking down. As an object accelerates, its relationship with space-time changes, not gradually, structurally. Time for that object slows down relative to an outside observer. Lengths along the direction of motion shrink. These are not side effects, they are the mechanism. The closer an object gets to the speed of light, the less additional speed means in ordinary terms. Velocity stops behaving like a simple rate of change. Feynman stressed this point because it exposes a deeper truth. The equations are not punishing speed. They are protecting consistency. Energy blows up because pushing past the speed of light would require time to stop completely for the moving object. And time cannot stop without destroying the order of events. Infinite energy is not a physical demand. It is a mathematical warning. A signal that the theory has reached a boundary it cannot cross without contradiction. This is why no object with mass can reach the speed of light. Not because mass is heavy, but because mass is tied to time. To exist as an object is to experience time, and the speed of light is where that experience collapses. Light can travel at that speed because it does not have a rest frame. It does not experience time. It does not move the way objects do. This is not poetic language. It is a precise statement about how space-time treats mass and energy. Trying to accelerate an object to light speed is not like revving an engine. It is like trying to erase the object's own timeline. The universe refuses. So the infinite energy requirement is not an obstacle. It is a stop sign, not installed by nature, but built into the geometry of reality. Once this is understood, the question shifts again. If mass, time, and energy are this tightly entangled, then they are not separate ingredients. They are aspects of a single structure, and that structure is space-time. Not as a backdrop, but as an active rule set that determines what can exist. The speed of light marks the edge of that rule set. Crossing it is not forbidden. It is undefined. And physics does not allow undefined realities, which leaves one final problem. If space-time itself enforces these rules, then where do those rules come from? That question cannot be answered by pushing harder. It requires thinking deeper. It is tempting to say that Richard Feynman explained why the speed of light is the limit. He did not. And that distinction matters. Feynman's contribution was not a new law or a hidden mechanism. It was clarity. Clarity about what kind of question physics is actually capable of answering. Again and again, when pressed for deeper reasons, Feynman refused to invent stories. He did not dress equations in comforting metaphors. He did not pretend that intuition was a reliable guide. Instead, he drew a hard line. Physics can tell you what will happen if the universe is arranged a certain way. It cannot tell you why the universe chose that arrangement. When Feynman discussed the speed of light, he treated it as a given, not because it was unimportant, but because it was foundational. You do not explain a foundation using the structure built on top of it. The constant C appears everywhere, not because light is special, but because space-time is. Feynman emphasized that trying to reduce this fact to smaller parts misses the point. This is why his lectures feel strangely unsatisfying to people searching for meaning. They are clean, precise, and deliberately incomplete. Feynman did not ask why space-time enforces causality. He asked how to calculate correctly given that it does. And the calculations work with astonishing accuracy. This is the uncomfortable lesson. The speed of light is not explained by deeper machinery. It is the machinery. When students asked why nature chose this speed, Feynman stopped. Not because the question was stupid, but because answering it would require leaving physics behind. At some point, every explanation bottoms out. Every chain of reasoning hits a final assumption. The speed of light is one of those assumptions. Physics does not justify it. It accepts it and builds everything else around it. That is not intellectual weakness. It is intellectual honesty. Feynman understood that the demand for ultimate explanation often hides a refusal to accept limits. Limits on intuition, limits on storytelling, limits on what equations can provide. The universe does not owe us a reason it feels comfortable with. It only owes us consistency. And on that front, it delivers relentlessly. So when people say physics still can't explain why light speed is the limit, what they really mean is this. Physics cannot turn a structural fact about reality into a human narrative. And maybe it shouldn't, because the moment it tries, precision gives way to illusion, which leaves us with one final realization. If the speed of light is not explained but accepted, then it is not a mystery to be solved. It is a boundary to be respected. And that changes how we think about understanding itself. At the end of this path, one thing becomes clear. The speed of light was never the mystery. It was the signal. We began by treating it as a number, a measurement, a record speed in the universe. That framing failed. Then we treated it as a barrier, something nature actively resists. That framing failed too. What remained was something harder to accept. The speed of light is not a feature inside the universe. It is a feature of the universe. It does not describe how fast things move. It describes how reality is allowed to unfold. Space and time are not containers in which events occur. They are part of the rule set that determines which events can exist at all. And the speed of light is the rule that holds them together. Once this is understood, many questions dissolve. Why can't anything go faster? Why does energy diverge? Why does time slow down? These are no longer separate puzzles. They are consequences of a single structure. Reality is arranged so that causality cannot be broken, not because it would be dangerous, not because it would be inconvenient, but because a reality without causal order would not be coherent. Feynman never tried to soften this conclusion. He accepted it. He understood that physics, at its deepest level, does not explain why the foundation exists. It reveals what follows once the foundation is accepted. The speed of light is one of those foundations. It is not derived, it is assumed. And everything else, space, time, energy, mass, is built around it. This is why attempts to explain the speed limit always feel incomplete, because explanation, as we usually mean it, requires something deeper underneath. And here, there is nothing underneath. There is only structure, rules without story, consistency without intuition. A universe that functions perfectly without caring whether it feels satisfying to human understanding. This is not a flaw in physics. It is a reminder. Understanding does not always mean reducing something to familiar parts. Sometimes it means recognizing that the familiar parts are not fundamental. Light does not define the limit because it is special. The limit defines light because space-time is special. And once that is seen, the question, why is light speed the limit, stops demanding an answer. It becomes a statement about the kind of universe we inhabit. A universe where not everything is explainable in human terms, where some truths are not conclusions, but starting points. The speed of light is one of them. Not a mystery waiting to be solved. A boundary that tells us where explanation ends and structure begins. And that may be the most unsettling discovery of all. Not that reality has limits, but that understanding does.